Hey, physics friends. Sorry I couldn't be with you today. I have a daughter that has conjunctivitis, commonly known as pink eye. In fact, she's got two pink eyes. So, I'm here recording. You say hi.
Hi.
This is Sadie. This is my middle daughter. We're here. I just wanted to go through the quiz with you so you kind of had an idea why the answers are what they are, and then we'll go hopefully see you on Monday. 1 second, Sadie. I'm going to do this and I'll be right with you, sweetheart. Number 1, can an object be moving forward if the force of friction is bigger than the force pulling it forward? If I had said, can an object be accelerating forward if the force of friction is bigger, the answer is no. But you can totally be moving forward. You're just slowing down. Like, that means that the force must have been bigger in the past. So the answer is yes, it can. A. It can. It's just not accelerating. Number 2, is the normal force always equal to the weight of an object when you're on flat ground? No. A really good example of that is down below when I asked you to find the normal right here, because this thing has a weight, the force of gravity of this thing is 98 newtons. If you break this piece right here into its x and its y components, this would be like 35.4, I believe, and this is also 35.4. So this normal in this case, the normal in this case is 98 minus 35.4, which comes out to be 62.6. This piece plus this piece equals gravity. So here's a really good example where the normal is not equal to, you could even go back one chapter when we're sitting on the elevators. If the elevator is accelerating up or accelerating down, the normal force is not equal to gravity in any of those cases either. Just to kill this problem, I could calculate the force of friction. It's the coefficient of friction, which is 0.250 times the normal force, which is 62.6. And that comes out to be 15.7 newtons. Going back up to the multiple choice. The reason I omitted number 3, you totally can. And so I was like, can the force of friction be bigger? Yes, it can. If you've got like something adhesion, like some chemical, it's sticky to it, or like Velcro, yes, you can totally have that. I just didn't want you to, I wanted to omit it because, in the traditional sense, no, but in weird scenarios, yes, you can. So I didn't want to get into it with anybody. Number 4, which must you first overcome? That is static friction, letter A. You did a wonderful job there. Number 5, I think number 5 is probably the hardest problem of the whole quiz because there's a lot going on here. Where you start with problems like this is you should be drawing a picture. So you've got a truck here, and it's got a mass of 2250, but that means it has the force of gravity acting on it. There's also a normal force acting on this, and then there's friction slowing it down. So I think we can actually calculate all these things. It's skidding to a halt. So this thing, it's moving forward, slowing down to a stop. I don't want you putting arrows. Only forces should be on your free body diagrams. I know that there's velocities associated here. I'll put my velocities up here. I'll say that my initial velocity is 26.8. And my final velocity over here is 0. I'm actually looking for the displacement. So that's what I'm looking for. To find my force of gravity, I take the 2250 and I multiply it by 9.8 and I get 22050 newtons. And that's what the normal force also is. I can then calculate my force of friction by taking the coefficient of friction. Interesting side note, this is how anti-lock brakes work, is when your tires skid, they have less friction than when your tires stay in contact with the ground. So you can actually stop in a shorter distance safer if you've got anti-lock brakes. So since we're skidding, we're not using the static, we're using kinetic friction. So you take the coefficient, 0.875, times the normal force, and you get your force of friction, which is 19,294. So what I'm going to do is I'm going to find the acceleration. And it turns out my net force is friction. My mass is 2250, and my acceleration is unknown. So my acceleration comes out to be a negative 8.575. It's negative because I'm slowing down, and because I also said positive is this way. So then I would go Vf squared equals Vi squared plus 2AD. My final velocity is 0. My initial velocity is 26.8. The acceleration is negative 8.575. And I can solve that for my displacement, which turns out to be 41.9 meters. Takes me about, I don't know, 120 feet-ish to stop. That seems like it's in the ballpark. I did this problem already, and I'll go down to the last problem, which is finding, you're in an airplane. So what's happening is your airplane, you're pointing it 25 degrees at 150 miles per hour, and this is 25 degrees. And then the wind is blowing you this way, 15 degrees at 65 miles per hour. And that is 15 degrees. Now there's two ways to do this. You could put this, and on my key that I did for you on the back of your quizzes, I put this on top of the end, and then I just use the sum of all the x and y coordinates, or I could just leave it over here, which I look like a lot of you were doing, so I'm just going to leave it over here to show you. All I have to do is I have to find the x coordinate and the y coordinate of each of those. And I'll find this x coordinate and this y coordinate. And using sine and cosine, and you got to be careful that if this is 15, that means that this angle right here is 75. So I would say like the sine of 75 degrees is equal to the opposite over the hypotenuse, 65. So then that y turns out to be 62.8. This x, I would use the cosine of 75. That turns out to be 16.8. And then this one over here, that 25, I'd use the sine. I'd say the sine of 25 is equal to the opposite over the hypotenuse, 150. So I take 150 times the sine of 25, and I get 63.4. And then this one over here, I take the cosine, 150 times the cosine of 25, and you get 136. Now I'm going to add up all of the velocities in the x direction. So I've got a positive 16.8, and I've got a negative 136. So that comes out to be negative 119.2. And then I'll add up all my velocities in the y direction. So they're both pulling up in this case. So it's 62.8 plus 63.4. And that turns out to be 126.2. Now I know the total velocity in the x and the total velocity in the y. So my total velocity in the x is going to be to the left at 119.2. My total velocity in the y is going to be up at 126.2. So I'm going to use the Pythagorean theorem, a squared plus b squared equals c squared, to get my last piece, and that's 174 miles per hour. And to figure out what direction I'm being blown, I'd find this angle by using the inverse tangent of the opposite, 126.2, divided by the adjacent, 119.2. And that angle comes out to be 46.6 degrees north of west. Or you can do its complement, which is 43.4 degrees west of north. I'd like you to work on the rest of that worksheet today with your friends, and we'll kind of do the same drill. I think that your sub has got another quiz for you to try. I'll correct that over the weekend if I can. I'm going to do my best with deer hunting coming up and a sick child. But I hope to be back Monday, so we're ready to go Tuesday for our test. We'll talk to you Monday.